So now we're going to start talking about servers. And the first part of this course, we were talking about templates. The next chunk, we're going to be talking about servers. And just so you could connect that with the code pathway, from 0.2 to 0.13, we're talking templates. From 0.14 to 0.21, we're talking servers. And we're going to build up our own server. We're going to do a TCP server, and we're just going to build it up at the network level using the net package and TCP to be able to do stuff, right? And so I just want to give you a little bit of an overview of how networks and HTTP and TCP and all that works and how servers work. So the first thing I want to share with you is this resource right here. And so github.com goes to 11 Golang web dev. And if you come down here, understanding servers, I have a little bit of a README file. And the first bit is just synonymous terms for talking about servers. So as you're going through the documentation of the standard library, you'll see mux and serve mux. What the heck's a mux? Sounds like some kind of a dog, right? And so these are just different ways of saying server. Colloquially, everybody says server or web server, right? But you could say multiplexer. A multiplexer in like electronics and engineering is something that makes decisions about routes and electricity. And so it'd be like, hey, this way, that way. And that's basically what a server's doing. Right? It's like a request comes in and then it makes a decision as to what needs to be done, what code needs to run. And so, multiplexer, mux, serve mux, server, router, request router, all of these words can be used interchangeably in web programming. Those are all synonymous terms. And you could even drop HTTP in front of that. So HTTP mux. I like the word mux. I think it's awesome. So that's the first piece. Know that, synonymous terms. The second piece is understand a little bit about the web and how it works. Clients, servers, clients make requests, servers respond. All right, this is called the client-server architecture. And just from a very basic introductory standpoint, think about a restaurant. You have clients in restaurants. You have servers in restaurants. Clients make requests to the servers, and the servers fulfill those requests. So the client might say, can you get me some more French fries, please? And the server would go get them and come back and, fulfill the request and give it to the client. And so that method, that verb, get, can you get me, is also a method verb that we use in web programming. Can you get me this page? What page? The page of this URL. Right? And so we send a request to the server for a certain page, a certain URL. And based upon that URL, the server is going to run a certain kind of code. Right? So if you ask for the about.html page, the server is going to say, oh, I'll give you the about.html page. And if you ask for the contact us HTML page, server gives you the contact HTML page. Right? And so the server is multiplexing. It's a mux. It's a multiplexer. Based upon certain conditions, it's making a decision about what needs to be done, right? And so that's the next thing you need to understand is this client-server architecture. Request comes in, server makes a decision about what to do based upon the route and what's asked for, and the method. There's all kinds of HTTP methods. Primarily, we're just going to look at get and post. Get means get me this page, and then when if a client received a form and then they sent it back, they could post that data back to the web server, and the web server would say, oh, it's this route, the method's post. I need to store this data in the database. So I'm saying all that fast because this is just the high-level overview. You could go back through and watch this video again, but the main takeaways, synonymous terms, right? Client-server architecture. Clients make requests to the server, and the server fulfills those requests and writes it back. And then the next thing are just how is that entire network, internet thing structured? How does it work? And what's the deal with all that? And so the way that works is there's something called the Open Systems Interconnect Model, the OSI model. And you could go to here and check it out, right? Open Systems Interconnection Model. And it has this entire stack thing about networks where you've got the physical layer, all these different layers, right? But different things happen at these different layers. Like here is the physical actual wires and, things like that. Here we have transport. Right? So this is the transporting things back and forth, and this is TCP, Transmission Control Protocol, right? So TCP is moving things back and forth. And then HTTP would be up here. So to understand servers, right, we have to understand a little bit about TCP and we have to understand about HTTP. And so TCP is moving the data back and forth. HTTP is a protocol that runs using TCP on top of TCP. And so HTTP is this protocol. It's written by the Internet Engineering Task Force, the IETF. IETF, right? And so they make up recommendations for about how the internet should be built. And they send out requests for comment. And so the most recent one is request for comment 7230. And you could go in and read this. It's a great read. and you could see things like, how should this message be structured, right? And if you look at the structure of this message, an HTTP message can either be a request from a client to server or a response from a server to client. Everything we just said. The two types of messages differ only in the start line, which is either a request line or a status line, and in the algorithm for determining the length of the message, right? And so what does that look like? So this is what it looks like right here. We have, this is the structure of an HTTP request, and this is the structure of an HTTP response. The request has a start line, which is the request line, headers, and optional message body. The response has a start line, which is the status line, headers, and optional message body. Okay, and so that request line has a specific format, and you can see that request line right here. Method, request target, HTTP version with spaces in between. Method, request target, HTTP version with spaces in between, carriage return line feed. So this would be like get /about space HTTP 1.1, carriage return line feed, and then headers, right? This would be a response, has the HTTP version, the status code, reason for age, carriage return line feed. So this would be HTTP 1.1, 200, okay, right? So that's like everything was okay. Or this would be like HTTP 1.1, 404, not found. So that would be the status code 404, not found would be the reason phrase. And you could check this out. If I went to like Reddit and opened up developer tools and hit enter and then watch all of the stuff come down and then click on this. And here are like general and response headers and request headers. And here's like the content type is text HTML. Those are the headers. So that's pretty cool. And we could even run curl, right? So curl, and this is just like a little program. Right? Just gave me a whole bunch of stuff, but I could scroll up to the top of that. And I could see kind of what's happening. And so, scroll up, sorry. Here we go, curl v google.com. Redirect, status, stage, get /HTTP1. So there is the request line, like the method, the URI, the URL, the route, and then the version, right? So there it is right there. And then we could look back through this to kind of check other stuff out, just see what else is in there. But that's the basic structure of an HTTP message. Here are all the headers. You can take a look at them. There's that little curl thing, right? Also maybe do Golang, see what comes up with that. Boom, 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 boom. Shell. So there it is, the first part. And then here's the response. Version, status code, method, right? And then here are the headers, right? Content type, text HTML, and then we have a blank line, right? After all that content length is another header, and then we have a blank line. So that's the structure of an HTTP request and response. It starts out with the start line, the request line, or the status line, and that's really important to know. All right. A little bit of an overview, and here's a little bit of a review on that. All of these terms are synonymous. It's all client-server architecture with clients making requests to servers and servers responding. Just remember that, the request and the response. That's a really important piece as we get into looking at the details of all this. And that those requests and responses have a certain structure. That structure is determined by the HTTP Hypertext Transfer Protocol, which the IETF is the organization that puts out the request for comment. The most current one is RFC 7230, and that's what defines the structure of that HTTP request or response. So that's the beginning. And in the next videos, we're going to look at how do we start building our own servers using just the net package from the standard library and working on the TCP layer.